Lesson, average rate of change. In that, we're going to refer to it also as slope, because I know you've seen slope before in Math 1 or before. This is 2.2.3. Okay, so that helps us know just what we're looking at. If you need to search Khan Academy for some other videos, you can use that title. That'll get you there. Okay. So just to remember, this is what we've done before. We already know the term slope. In this case, when we're dealing with models, when we're dealing with our parabolas, we're talking about the average rate of change. But as far as how they function, as far as how we work them out, it has the same approach as when we're looking for the slope. So if I'm talking about my rise, I'm talking about my rise. Am I talking about my x or my y variables? My rise up and down? I'm talking about the y. Okay. So the rise, remember, is talking about your change in y. The run is talking about your change in your x value, side to side. Rise over run. Okay. These can be negative or positive. So when you're going from one point to another, you have to look and see, is my rise positive, or could it be going in a negative direction? You have to make sure you're noting that as well. Okay. So let's just go ahead and look up at these problems. Maybe you're going to jot down one of these two graphs, but we're going to look in, just like the warm-up, just to review, we're going to look and see, okay, the rise over the run. From this point to get up to this point, think of an elevator. How many floors you have to go up? 1, 2. Okay. The rise is just going to be 2. Positive direction. Then we're going to go from this point to the point over here. And we're going to go over 1, 2, 3. All right. We're not counting from the origin. We're not counting from the axis over. That's how we find the point. But instead we're finding from that one point, how far over do I go? It's towards the positive 1, 2, 3. So if we're counting from the origin, it's 4 over. But we're counting from where this point is. It's over 1, 2, 3. Okay, that's a common mistake. So let's make sure that we're counting from just the point to the other point. So here we had a rise of 2. We have a run of 3. 2 over 3. So that would be my slope. That would be my rate of change between those two points. Okay, now I look on this side, and I want to see what my rise is. So again, don't make that mistake of counting from the origin up. We're counting from this point up to that point. So if you're thinking of like an elevator, you might be in the basement. You're at -1 here. So how far up do you have to go to get to the other point? Let's see. You go up 1, 2, 3, 4, 5. So we have a rise of positive 5 in that case. So I'll put my 5 at the top. That's my rise. And then looking again here, we have going from this point to this point. What is my run from side to side? 1, 2. Just 2. Positive 2 in this direction. Positive. Can I reduce that fraction? You could make it into a mixed fraction, but let's keep it like that, nice and improper. And those are our two slopes. So if you're just given 2 points, you can count it out, or you can do the next step, which I know you've seen before. I'm kind of ramping up a little slowly to this. So if you're talking about the next step here, this is kind of a new section. So when given any 2 points, we're given any 2 points you can think of, we can always find the slope between them. Okay. So the key here is, and I'm going to reiterate it as I go, it doesn't matter. It doesn't matter which is my 1 group and my 2 group, as long as you're consistent with it. So you can decide, oh, this is going to be my 1 group and 2 group, or this is going to be my 2 group and 1 group. It doesn't really matter as long as you're consistent. But in this case, what they gave us was, first off, they just gave us 2 points. And they said, plug it into the slope formula. What would be the problem if I just said, okay, I'm going to plug this point up here and this one over there? You might get mixed up and disorganized, right? So this sub 1 and sub 2, you could even think of it as color-coded. That's why I want you to use those markers to color-code this. So it could be just color-coded. This is my blue group, this is my red group. But because we're working with multiple x's and we may run out of colors, right? We want to go ahead and say, okay, well, this is my one group, x1, y1. And this is my second group of x and y's. This is my x2, y2. Really important that y sub 2 isn't the same as y squared. I know that might be intuitive, but just to remind you, when we have these subs, that's just labeling it. It's saying, hey, here's my blue group, we're going to call that group 1. Here's my red group, we're going to call that group 2. And that's going to help us organize what goes where. Right. So looking at that, we need to access this slope formula. This slope formula here, I want you to go ahead and box it out, star it up. Slope, which is the rate of change. Rate of change is always going to be set up like this. Since it's the rise on top, the rise has to do with my y values, and we're finding the difference. We're seeing how much it rises by finding the difference of it. The run is my x values, and we're finding the difference between those two as well. Okay. So my first example we have here, we're given these 2 points. You're going to be given the points in a lot of cases. My suggestion for when you plug it in, use parentheses. Put a star next to it. I want this to be the next form that you write on your paper with the parentheses here. Because when I have negative values in my points, it's really easy to mix it up and forget about the positive negatives, and we're going to avoid that because that would be a half off on the quiz. So I know if I'm using my slope formula, I know that on the top left, or on the top of my y's, and on the top left here is my y sub 2. So what is my y sub 2 among my points here?
5.
All right. What is my y sub 1? I look to my groups. This is the group 1. 2. Okay, getting there. What is, I look down here, my x's are on the bottom. What's my x sub 2? 3. And what is my x sub 1? I look to my 1 group. All right. Now, we're going to go ahead and write out the slope in its final form, because once you get the values for x and y into your slope formula, then you just have to do a little bit of arithmetic. So what's 5 minus 2?
3.
And what is 3 minus 1?
2.
That's my slope, 3 over 2. That's all we have to do. So when we're given 2 values, first we need to identify what's my group 1 and group 2, just to keep organized. Then we go to our slope formula, put in our parentheses, and input in y sub 2, 5, y sub 1, 2. X sub 2 comes from the 2 group. X sub 1 comes from the 1 group. We work it out. We get our slope. All right. I've been told that you've seen this before in Math 1 or before that. You've seen this, you're pretty familiar with this. Okay. I'd say now that we're getting a little more complicated, just make sure that you use the parentheses. That's where the mistake's going to happen. That's the key right here. Because the positive negatives, we have to make sure that we're really solid with that. We don't want to mix those up. All right, there's only one other step, one other thing we'll have to do, and that is looking at, running out of space. That's looking at the case when we are given, this over. All right, that's the case when we're given a quadratic equation. We're going to be given this. You're given the quadratic, and you're also given, in the problem, you're given 2 values for x. 2 values for x. So in my steps, I actually switch these around. So number 1 is label one of the, let's just say that. Let's label our group that's going to be our x sub 1, y sub 1, and our group that's going to be the x sub 2, y sub 2. So I'm just going to rewrite that over here. Let's see. Rewrite it here. So let's see. This is my 1 group, and this is going to be my 2 group. All right. Now, how do I know which, I'm given these two x values, how do I know which one I'm going to choose to be in my 1 group and my 2 group? It seems tricky because it could be one or the other, right? The good part is right here. It doesn't matter which is the 1 or the 2, you just have to be consistent. Once you decide I'm going to label this my 1 group, and I'm going to put my 1 right here into it, then this 1 is now x sub 1. That's all. It's going to match to a y sub 1. And then I'm going to decide, okay, this 3 is going to be this is going to be x sub 2, so I'm going to put 3 in there for x sub 2. Now, when we know one of the values, we know the variable x. We have that figured out. We know what x is. How do we find what y is? We've done this before. What do we do? Plug it in, right? We had to do that before we give it an x. We have to find the y. So this is where I'm going to go ahead and show you to find this y sub 1. I'm going to take f of 1 because I'm plugging in 1 for x. I'm going to work it out and find my y. That may sound like a lot of work, but actually when you plug it in, as long as you're really clean with your parentheses, this is an easy problem, an easier equation to deal with. But when it gets a little trickier, you want to make sure that you have the parentheses to help with positive or negatives. All right, so when I plug in 1 for x, 1 squared is 1. 2 times 1, 2, minus 1. This is a positive. So that's pretty quick. We did that quick. 1 plus 2 is 3. Minus 1, 2. So I know when I plug in 1 for x, I get 2 for y. Almost done. What do you think we have to do to find the other y value? Yeah, plug in it again. Plug in 3 for x, because my x sub 2 is 3. So to find my y sub 2, I have to plug in 3 for x. And let's see what happens with this. Use your parentheses. 2 times 3 minus 1. That's right. All right, we'll work this out in 2 quick lines here. 3 squared, 9. 2 times 3, 6. Minus 1. All right, so let's do it out. 9 plus 6, 15. Minus 1, 14. So I just figured out when x is 3, my y is 14, so I'm going to put the 14 right there. Okay. The last step, you're just going to plug into the slope formula and simplify this. So I'm looking for my y sub 2. Where do I find that part of? Where do I find that information for y sub 2? So my group number 2, I just found out that it's 14. So I'm going to put 14. For y sub 1, where do I find that? I find that in group 1. My y sub 1 is 2. Question? How about my x sub 2? I look to my group 2. I'm going to use 3 because that is x sub 2. I'm going to look at x sub 1, which is positive 1, and I put it right in there as well. All right, now we just need to simplify this. 14 minus 2, 12. 3 minus 1, 2. So altogether we get a slope of 6. The rate of change is 6. All right. So what I just showed you was how to find the rate of change if you're just given 2 points on a graph. We found the rate of change when we're given 2 points. We can find the rate of change if we have a formula and 2 x values. We just have to do a bit of plugging in to find our 2 points, and then we use the slope formula again. What do you think the hardest part of this is? Hardest part? Maybe this side of the problem, it's just a few steps you have to do. Again, it doesn't matter which is the sub 1 or sub 2 group. Go ahead and just, you know, choose for yourself. Just be consistent from there on out. And then I want to show one more thing you have to do in the problems for your homework. So next, you're going to be given a graph. And I'll tell you that for numbers 3 through 6 in the workbook, this is kind of a hint on how to approach this problem, because they're going to give you x values of this. They're going to say x value is -1, another x value is 1. They're going to say find the rate of change between those two x values. Now if I go and I put a couple points here, it's going to give you a graph on the problem. So actually this will be pretty straightforward. But you'll go to the graph and you'll say, okay, I know that my graph has an x value at -1. So this is where I'm going to go to -1 on my graph, and I'm going to go ahead and just make a little line to point out. Where does the function, this parabola, where does it cross where x is -1 approximately? Where does that cross? What is the intersection of this -1 for my x and the parabola? Where do they intersect? Right there? So I know that this point right here, this point, is at -1, 0. I'm going to say that's my 1 group. So that's my x sub 1, y sub 1. Doesn't matter which one you choose. On the other side, they're saying, okay, now when x is equal to +1, where does it intersect? So when x is +1, it hits the parabola right here at +2. So this point right here is 1, 2. I'm going to say that's my sub 2 group. So this is x sub 2, y sub 2. Right? I just decided that as I was going, this is 1 group and 2 group. Doesn't matter as long as you have consistent. You can switch those and you get the same thing. So now I know x sub 1, y sub 1, x sub 2, y sub 2. Now I just need to find what the rate of change is. So let's see. We start by doing y sub 2 minus y sub 1. X sub 2 minus x sub 1. 1 minus -1. Parentheses are helpful because when it's a minus minus, we need to deal with that sign. We might be tempted, if we don't do the parentheses, just to leave it as -1 because it's -1. But with the parentheses, we're going to avoid that mistake. And we're going to go ahead and work that out to find our final answer here. So slope is, what's 2 minus 0?
2.
2. Negative times a negative gives us a positive. Excuse me. So 1 plus 1 is also 2. So our rate of change is +1. We're going to have this kind of situation for, I think it's numbers 3 and 5. Okay. Do we see how we found those points, though? We go to the graph. We look to see, okay, we know that the 2 points we're given are part of it. X is -1. I go to -1. I see where the graph crosses. It's here. So that's going to be one of my points. I went and looked where x is equal to +1. And where does the graph cross that? Up here. And that's the point 1, 2. 1 for x, 2 for y. You have your 2 points. Now we can find the slope from that. This might be the hardest part, but when you do the first problem, work together on number 4. It's number 4 and 6 that are like this. So on number 4, definitely work together on this. They're always going to give you, I think for all these problems in the classwork, they say, here are the given points for x, and they're going to apply to all the classwork problems. In addition, you have 2 sets of points here to find the slope between for the homework and classwork. It's just right up here. Go ahead and jot that down, just in your homework, classwork, wherever they fit. And let's jump right into it. I think that is a breakdown we can start to work with.